force. And the example I usually like to start with is one that I think a lot of us have experienced, and that's when a car goes around a corner. We end up feeling this force that's throwing, it feels like it's throwing us out of the car. Let's just imagine here, you're in a car, and it's traveling down the road that direction. So that's the way the car is going. Now you're inside the car, so we'll just draw you right there, and maybe you're sitting in the back seat or something, and you are moving in the same direction that the car is. So you and the car both are going up as I've drawn it on the screen. Now the car goes around the corner. All right, so a little bit later, just a few moments later, the car is now traveling in this direction. Right, you turn the wheels and the car is now traveling this way. But if you remember, Newton's first law said an object in motion wants to stay in motion. And so what happens is you have inertia and you want to keep moving in this direction. Your body keeps feeling like it wants to move in that direction. Okay. Now what this does is it pushes you, or it doesn't really push you, but it makes it feel like you're being thrown out of the car. But there's something there that stops you. And a lot of the time, what's there is like the seatbelt, or if you're hanging on to the steering wheel, you might do that. But let's just imagine here you got the car door. And what it's doing is it's actually applying the force, because your body is pushing on the car and the car is pushing back, and it's applying a force, causing you to go into this curved path. So you can say force subscript C causing you around going the curved path. And if we take a look, it didn't start just then. It's not like it just started there. I just usually do this as an example. But if you take a look, you probably started to feel it as you went around the corner here. So now the car is turning and it wants to go this way. And you would be in the car having this mass here, and you would still want to be traveling in that direction. Okay, this force that's pushing you back into the center has a special name, and we call it centripetal force. Okay, so centripetal force is a force that causes objects to follow a curved path. And you'll notice down there in the definition of it, it says center-seeking force. And it just helps us realize that when something is going around a corner like this, it's traveling in a curved path, but that really could just be the part of a bigger part of, say, a circle. And the direction the centripetal force is pointing is towards the center. So let's go ahead now and review some of the terms we learned in the lab. So we got center-seeking forces is what we call centripetal force, and then we have what we call centrifugal force, or centrifugal force, depending on how you do it. And you could refer to this as a center-fleeing force. Now, the important thing I want you to notice right away is that a centrifugal force isn't really real. There's no force causing it to be thrown out of the circle. If we go back to our example up above, is there any force throwing you out of the car up here? No, there's no force actually doing it. It's just the property of your matter, like you have matter in you, and it's that you want to keep doing what you're already doing, which we call inertia. But it can seem like there's some force pulling back on you. So what we got here is a picture of a yo-yo that's being spun around in a circle. And if you take a look at it, the yo-yo would be traveling in this direction, right? So it's moving that way right now. There's its velocity. However, when the yo-yo gets here, the yo-yo would have inertia wanting it to go out this way. It would want to keep moving in that direction. But what's preventing that from happening is the fact that you had a string, right? So you're spinning a yo-yo around your head, and you got a string pulling it back in, and you are providing that centripetal force back towards the center. Okay, and so we call it force centripetal. Okay, so you got these little things that's always going towards the center. No matter where the yo-yo is that you're spinning around your head, there's always a force caused by the string and then your hand pulling it back towards the middle. All right, so the way to take a look at it is you force the yo-yo back towards the center. So a little bit later it wants to keep moving out, but now you've changed its direction that you're actually causing it to move now, say, in this direction. So there's its new velocity. But then you apply this, center-seeking force right there. So a little bit later it's now going in that direction, right? But it still has its inertia from before, causing it to go back out. A little bit later, you force it back into the center. So now you've changed its direction, so it's going this way, but it still wants to feel like it's being thrown outward. And that outward feeling, leftover inertia, we'll put here in red, that is the sensation that makes it feel like there's a force working against you. And the key term we need to know here is that centrifugal force is not real. Okay, it's not a real force. It is a fake force, and it's really just an object's inertia. The thing that makes you feel like you're leaving the circle is not the fact that there's a force pulling you out there. It's really just your inertia from a little bit before. This is the way the object was moving, All right, it wants to keep moving in that direction, so we call that inertia. It couldn't do that because the centripetal force was pulling it in, and so this force changed the object's motion, so now it's moving that direction. Now, let's review this all from lab. I'm going to go ahead and clean up our picture a little bit. I'll erase some of the stuff we don't really need to have on there, as all this sort of things here. Okay, so we clean that stuff out of the picture. Let's talk about what actually affects the amount of centripetal force is acting on an object. And another way to think about a centripetal force is the amount of force needed to keep that object moving in a circular path. All objects want to travel in a straight path. So once again, we look right here, hit the wrong button. When the object was right here, it was moving. Its inertia wants to keep it going that direction, but we're not going to do it. We're going to provide a centripetal force, bringing it back in. So how do we calculate that? Depends on a couple of factors. To calculate centripetal force, we figured this out in lab, so you should have this in your lab notebook, but force centripetal is equal to the object's mass. All right, so we got that out here, multiplied by the velocity squared that the object is traveling, and this would be its straight line or linear velocity, divided by the radius that it's moving at. And you would just simply get that by the radius of the circle. All right. Now this is how you calculate centripetal force, the force needed to move an object in a circular path. All right, next video, we're going to take a look at a sample problem on how to use it.